Hey guys, today we will continue with FPGA Academy. Today we will look at the first lab. The first lab will be about switches, slides, and multiplexers. And last time we did the first tutorial. It was about Quartus, and we created our first project. If you haven't seen the video, if you haven't seen the stream, you can go to my YouTube channel, white brackets, and here there is the first video. So you can watch that, and we will start with today's lecture. So today we'll look at the first lab. I have the PDF open here, and let's start. The purpose of this exercise is to learn how to connect simple input and output devices to an FPGA chip and implement a circuit that uses these devices. We will use the switches on the DE series boards as inputs to the circuit. We will use lightning emitting diodes, LEDs, and 7-segment displays as output devices. Okay. Part 1. The DE SOC board provides 10 switches and lights called like that. Similar, the DE, we don't need that. Okay, I think the first exercise is just about connecting switches to LEDs, and it's about importing the pin assignments. So we will do this and import the pin assignments. So I'll open Quartus, and we will make a new project. Again, we will go to this FPGA Academy. Okay, I'll first make a new file. So FPGA Academy lab 1. Okay. And so lab 1. The name of this project is gonna be let's call it part 1. Okay, let's finish. Okay, let's create a new file, VHDL, and I'll probably just copy this. Just text, no. Okay, I don't know if I can, I can just copy this. Okay. Let's call it, yes, part 1. Okay. Got the ports. This and the architecture. So here we just have the ports, we have the switches and LEDs, and we just assign switches to LEDs. So it's really simple, but we have to, since we don't have any assignments, we don't know where the switches and LEDs are. We have to import them. So we'll do this now. We can go here and in the boards. I think here, this file, I'll download this file, and I will move this file here, downloads, and yes, and move it here. And now we can import to Quartus. So open Quartus and let's import assignments. And here we have the file. Okay. And if you look at the assignments now, we can see that we imported all the assignments. So we have our switches, and so we have our LEDs here and our switches. we have total 9 switches and 9 LEDs. So we can just, so here we can see we have 9 inputs and 9 outputs, which correspond to the LEDs. So we can compile this project. Yeah. So create this project. Wait, did I? Yeah, I didn't select the device, so I have to select that. I'll select the DS. Oh, I mean, we have to. I'll just do this, delete it, and I'll maybe import it again, so there is no issue. Okay. Now we should be able to compile. Okay. Create a VHD entity. So we did that. Include in your project the required pin assignments. Yes. Compile and test it. Yes. Okay. Let's see. There's some problem. End of file. I think there has to be a semicolon or just end of, yeah, like this. Let's see if it compiles now. No, there has to be a semicolon maybe, I think. Yes, now it compiles. And we can test it out on the board here. Okay, let's read the second part. Figure 2a, that's this one, shows a sum of products circuit that implements a 2-to-1 multiplexer. Yes, this is a 2-to-1 multiplexer. With a select input S. So here we have our select input S. And yeah, if S, then the M output is equal to X, and if S is equal to 1, then Y gets selected. Yes, so here's the VHDL code for this circuit. Okay, we have this done, so we can program. Let's auto detect, select the correct chip. Yes, select the FPGA, not the ARM processor. We select the output files, and yes, okay, here, program, and start. Okay, so now we can see that if I turn on any of the switches, the corresponding LEDs turn on, so everything works as expected. Okay, so we can continue. So let's create a new VHDL entity. So let's go to files, create a new file, VHDL, and we will call it. So here is a snippet of a code in the future that we will use, and we will call it MOOCs 2-bit, or maybe, yeah, let's call it just, let's create an entity. Okay, let's copy this code, and we'll create MOOCs 1-bit 2 to 1. Yes, so let's call it like this. And so we have to create a multiplexer. Okay, include in your VHDL5 for the 4-bit project use switch as okay. Okay, let's read the rest of the. You are to write a VHDL entity that includes 4 assignment statements, like the one shown above to describe the circuit given in figure 3A here. So here we have one select, and we select. Okay, I see. We select either X or either Y, and X is 4 bits. Okay, let's do that. So let's create this first. It's gonna have port. I'll do it like this. Entity is okay, port, and we will have one input, which will be std logic. Then we have another input, which will be that will be X or Y. So we have XY, std logic, and then we have one output, which will be called M. So like this, like this, and let's create the architecture. Like this for this, and the architecture will be the code here. Not and or and. So we don't need this. Either yes. Either if S is 0, we select X. If S is 1, we select Y. So this should be correct. We will not call this part 1. We will call this mux 1 bit 2 to 1. Okay, and now let's create a new file, new VHDL, and again let's copy this part, and this we will call part. Let's call this part 2. And here you have port, and here we will import. So we are supposed to connect LED 3 to 0 and switch 9 and switch so switches 3 to 0 as X and switches 7 to 4 as Y. Okay. So basically we import all the switches except for 8. Okay. Let's import all the switches. Switches in as in, and it will be std. And now I have to look at the syntax. Std logic vector. Std logic vector 9 down to 0. We will have LEDR as output. Std logic vector 9 down to 0. And here it's gonna end. And that's all we need for the ports. And now we will create a architecture. Architecture part 2 is, and we will create this component. So component port and so end component port, and we have just one bit. So what I'm doing now is I will import the code we created. Oh, I included this here. Wait, let me fix that. So, and I will move the file from output files mux, and I will import mux 1 bit 2 to 1 bit VHD. So now I moved it back here. We'll remove this, and we will go to assignment. Assignment settings files, and here we select the one we want, which is this one, and apply. Okay, so we have our MOOCs, and I'm importing this MOOCs into our code here, into our code, not here, into our code here. Let's call this part 2. Save. Into our code here, and we have in total we have 3 STD logic inputs. So I'll just copy this. So copy it like this. So we imported this, and now we'll begin the architecture. So we need in total 4 of these. So I'll here create 4. I think I have to import them 4 times. Importing components VHDL. I have to look at the syntax. I'm not sure about how to create 4 of the same. I think I have to name it different, but I'm not sure. So here we have component FA. Okay, so it's probably like this. Oh yeah, here. Okay, so the way we do is we do, let's call it LED 1 MOOCs, LED R 1 MOOCs, then this, and MOOCs, then we copy this, and we put no port map, and yeah, here we put switch. So in the description they said we are supposed to connect here, part 2 here. We are supposed to connect switch 9. Yes, switch 9 as S. So here it will be switch 9 like this, or I think like this. Then, so that will be our S, and X and Y. We will connect 7 and 3. LEDR 7 and LEDR 3, and SD, wait, no, that's switches as well. And as our output, we will connect LEDR 3 like this. And now we copy this 4 times for first, second, third, and fourth LED. Here we write 2, 1, and 0. Same here. 2, 1, and 0. 6, 5, and 4. And this will be the same. Okay. So I think that's it. Custom. Yes, we have the assignments, right? Or did I? Yeah, we have the assignments already imported. So I think we are ready. Okay, we have to end this, and I think that's it. Let's try it out. Let's see if it works. I'll have to change the, or I have to do it here. Change the, or set it as top level entity. So now we will compile the part 2 as the top level entity. Okay, let's save this and try to compile. See if we have any errors or if it compiles correctly. And then we will do part 3. In part 3, okay, there's some error. Architecture off here. Okay, then have it wrong here as well, I think. Architecture off. Okay, let's try it now. Okay, let's look at the syntax. You can look part 1. So we have architecture behavior of is. Okay, architecture behavioral here. Let's copy that here of is, and we will do the same here. Architecture of is. Let's try it. Let's try now. Yes, now it seems to work, so that's perfect. So let's look at the part 3. In part 3, we will change the 2 to 1 to 4 to 1. As in the... And they say we can use... So, recall from figure 3 that a 4-bit wide 2 to 1 multiplexer can be built by using 4 instances of 2 to 1 multiplexer. In figure 3. Yeah, so here we created 4 times or 4-bit 2 to 1, and now we will create 2-bit 4 to 1, and they say we can use 3 times the same circuit. So there is probably easier way to do it, but I will do it as they show. But first, let's try it if it works. Okay, I programmed, and so Okay, seems to work. So let's select the first two on the switch 1 and second two on, or like this, second two on switch 0, and now I can switch in between. So now we are controlling them here, and if I switch, I can switch these as much as I want, but they don't react. So it works correctly. So now we have the first 4 off, the first 4 on, and I can just switch with switch 9 between them. So our design works correctly. Let's move on. Let's try to do the 4 to 1. So I will create again a new, no, not add, I want to create a new one. Let's create a new VHDL file. Let's copy this. Let's copy this here. Okay, I'll close all the ones I don't need. And let's copy it here. And we will call this MUX 2-bit 4 to 1. And as input, let's look at here. We will do the same as here. So as input, we will have std logic vector. So, and UVX, okay. So we have X and S and U, V, W, X in std logic vector 1 down to 0. Okay, and out will be also std logic vector, and it's gonna be called M. Okay, so we will, as we did in part 2, we will import the component. I will import this component. And what do we want to, not here, here. Let's call this, let's save this file as MUX 2-bit 4 to 1. Oh, it saved here again, right? Okay, see. And CD lab 1, lab 1. Wait. Here, it's clear, and go to lab 1 and copy, so move, and I have to 2 and 4 here, 4 and 2 here. Okay, so it's back here. Okay, let's delete this, and again, assignment settings, files, and we will add this one. Okay, so okay, let's continue. So we want to have 3 of these. We want to have 3 of those as shown. So let's, okay, I'll write it here. So here we have, where is it? Here we have 3 switches. So I will create 3 2-to-1 switch, 3 2-to-1 multiplexers. Okay. So MUX 1 will be this. map port, and we'll map. So we have so for this one we will use S0, then we will input U and V. Wait, but U and V is... How is it done here? U and V are all... Okay, I see. So U and V are 2-bit. Okay, so I'll just put U, but U... Okay, we have to create a 2-bit then. We can... Okay, I see. It has to be like this, I think. Because it's gonna be 2-bit. So we have to change our design. I will rename, or I'll just create a new one. Okay, create a new file. This time I'll try to... This will be 2-bit. And the only change we will do is we will put std logic vector 1 down to 0, 1 down to 0, and that's the only change. Here we have also 2-bit. Okay, I'll call it mux 2-bit 2 to 1, mux 2-bit, and now we save it in the correct location. Okay, so I think this is correct. Or no, the output has to be also std logic, right? Because that's what we select. And now it should be correct. Yes, I think so. So let's go to our 2-bit 4 to 1. We will also do this for here. Like this. And UV. And the output will be... And here it's a little tricky. We have to create signals. We have to create signals for these 2 signals. So that's done like this. Like this. So we create signal. Okay, we'll call it... where do we create? Before begin. So here. In this part, we create... Let's call it mux1 out. Mux1 out. It's gonna be a signal. And it's gonna be std logic vector like this, and we need 2 of these. So mux2 out, and here we assign the mux1 out like this. Now we copy this. Let's create the second one. Here we assign it as to the second output. Okay. What do we... And now we need the final mux. So mux1 and mux2, they will correspond to these 2 muxes. Then we have the signals. Those are mux1 out and mux2 out. And these will be inputs to the final mux3. So this is mux3. And this will... Okay, we have to change also the inputs here. There will be W and... Not X and W. X and W. And here the inputs will be mux1 out and mux2 out. And this will be mux... We don't need mux3 out. This will be just the final output M. And I think now it should, so, okay, let's see what we have to do to finish this part. So create a VHD entity for 2-bit wide. We have done this. Connect its select inputs to switches. Okay, like this. And also use switches to provide the 4 2-bit inputs. U to X. Yes, I see. Okay, so we will use the first 2 switches. So let's create a new file. We will call this, let's copy this part. We'll call this part 3. Part 3. And we will import the switches again. And here we don't want this MUX, but we want MUX 2-bit 4 to 1, and we just need 1 in this case, right? Because here we will input, yeah, like this. So this will be 9 down to 8. This will be, okay, I'll put it underneath. So this will be down to 6, down to 9 to 7, 5 down to 4, and this MUX has in total 5. I'll copy this part to the, let's save this as part 3. So in part 3 we import the component MUX 2-bit 4 to 1 with these ports, and we say the switch will be the switch for the MUX will be switch 9 to 8, and then we have 4 other. So I need to copy this 2 more times. This will be 3 down to 2 and 1 down to 0, and this will be, this one will be 1 down to 0. I think that's how they want it in the, yes, LED 1 to 0. Bin assignments and test it. So I think now we are done. Let's try to compile it. So we created 1 MUX as described here. We have 2 switches, switch 9 and switch 8 as the switch for the MUX, and then we have U, V, W, and X here, and the final output will be LED. Okay, got some syntax error. Let's look at that. Oh, and I need to hierarchy. I need to set part 3 as top level entity, but we have some error on, I think it's port map, right? It's port map, not map port. Wait. So the correct is port map. Port map, and here I have this map port. So let's delete this. Map. Map. And map. Now it should be fine. And in the, again, we get some error. MUX 1-bit 2 to 1 is used but not declared. That's because we have to change this to 2-bit. Okay, and 2-bit 2 to 1. Okay, let's see. Finally, this should be hopefully working. again some, wait, what? 2-bit 2 to 1, 2-bit 2 to 1, can write to interrupt object M of mode in. Oh yeah, here we have, we forgot out. Okay, so default for the ports is in, so basically you don't even have to write in here, I think. S here. Wait. Oh yeah, here we have to do this. Wait, 2-bit 2 to 1. Do I need? I can see what the error mean, but now I'm not sure how to deal with this. Because, okay, let's see. Hex. So we are doing the part 2. So 0, 0, we select this one. They want us to do this. If I have to do case in this case, like I have to do switch in this case, or I think it's called, okay, let's try to find switch case VHDL. Case when, that's how it's called. So case is when, yeah, case, case S is when S, when, and no choice, so when 0, we will do M will be assigned X. When 1, M will be assigned Y. Now it should work. Let's indent this and end case S. I hope this works. Get some syntax error. Case expression. So let's see example. Maybe you can use case in, yes, you have to use it in process. Okay, not case, let's use, yes, this is when. Okay, when selected, yeah, with. This is what I wanted. Okay, let's just copy. And so with S, select M, and it'll be M when 0. And here there'll be, no, not M, X when 0, and Y when when one like this. Okay, let's see now. Now this should work, I think. Looks to be 2 to 1. Four to 1. Okay. A lot of syntax errors. Let's see now, hopefully. Okay, finally we get it working. And I will select, so here I will select U as 0, 0, V as 0, 1, W as 1, 0, and X as 1, 1. And then I will switch between them using S1 and S0. So let's program. And okay. Let's do it like this. So now all the two switches S0 and S1 are these. They are turned off. So they are selecting the first two switches, these two switches. If I turn this on, then these two are selected. Then I can turn this one, the third are selected. And if I turn both of them on, then the final one are selected. Now I can do this, but these do nothing, only these two. So this seems to work correctly. Let's try it out. Okay. Yes. So this seems to work correctly. So today we finished part 1, part 2, and part 3. There was a lot of syntax errors, but we learned something new. We learned that if it's not process, we can't use the case, but we have to use with. And yeah, next time we will look at part 4. We'll work with hexadecimal or 7-segment display with hex numbers. And in part 5 and part 6, we will develop some more interesting stuff with 7-segment display. I thank you for watching. I hope you enjoyed, and I'll post this again on YouTube so you can watch it there. And I hope you enjoyed, and I'll see you next time. Bye.